Hi everyone. Today we'll take a look at range of quadratic functions. All right. So the quadratic function, again, whenever we discuss about it, it's always going to be in the form y is equal to ax squared plus bx plus c. All right. So let's look at when we have an upward facing parabola, or when a is equal to 0. Okay. So when we have a is equal to 0, our range is from minus d by 4a to plus infinity, or just infinity, where d is basically our discriminant, b squared minus 4ac. Okay, that is basically the range, right? Okay, and the x value which corresponds to the range is minus b by 2a. Now there are multiple ways of deriving this. I won't necessarily spend any time deriving it, but what I can tell you is if you remember your calculus, and if you're using this video as a revision video, you can find the derivative of this general function right here. So what you get is dy by dx is equal to 2ax plus b, right? So what I can do, I can just quickly show you what we do here. So I can just say dy by dx is equal to 2ax by b plus b, sorry, right? So if this is the lowest point, right? So if this is the lowest point, the slope here has to be 0 because it's got to be a flat horizontal line like this, right? Passing right through. So if the slope is 0, dy by dx is equal to 0. So we have 2ax plus b is equal to 0, and x is equal to minus b by 2a, right? That is how we essentially derive this, right? That is the turning point of of this graph, of this quadratic function, right? Similarly, when we plug in minus b by 2a for x everywhere, what we get, if we just rearrange everything, what we get is minus d by 4a. So essentially our range, what happens to range is that our range, another way of writing it is basically 4ac minus b squared upon 4a. We can write it like this as well, right? That's another way of writing it. So whatever you like, you can use that. I just remembered as minus d by 4a. That way I don't confuse myself anywhere here. But yeah, you can do whatever you want. So now I just want to make one thing clear here. I've drawn this graph like in this manner. But what I really want to tell you guys here is that you can draw this graph this way as well, or this way as well, right? As long as it's an upward facing parabola, it doesn't matter, even if it's like this. Essentially, the only thing you need to understand here is that its range is from minus d by 4a all the way up to positive infinity, right? And obviously, its domain is all real numbers, right? There is no constraint here, right? We will look at a question where there is a constraint, where where the question will restrict the domain for us, and in that case, we'll have to find the range. Okay, so that's for later. But yeah, so this is for a is greater than 0. Now let's look at when a is less than 0. Same thing remains, right? Now what we have is from minus d by 4a, we're gonna have it going to minus infinity. All right. Notice how I've put a square bracket here, right, and then a parentheses here, right? So I just want to remind you guys that when you have infinity, right, you can't define infinity; it's undefined, right? Therefore, we put it in a parentheses, but we can define this, right? The range is what we're saying is that it includes this value and the numbers beyond it. Similarly, it includes minus d by 4a all the way up to minus infinity, which we don't know where it will ever end, right? Because it's ongoing forever. It's such a huge number, we don't know, right? Again, here as well, the range can be pretty high. You can start from a positive value as well, right? Minus d by 4a can also be a positive value. It doesn't really matter. So same thing applies here. Nothing too crazy. So now let's look at an example question. All right, so we have the question, let p of x, ax squared plus bx plus 8 is a quadratic polynomial. If the minimum value of p of x is 6 when x is equal to 2, find the value of a and b. Right, so let's extract some information before we start. Okay, so first thing they say is if the minimum value, right? If they're saying the minimum value, that means we have an upward facing parabola. Or we can say a is greater than 0. Because only in an upward facing parabola can we have a minimum value, right? We can only have in a downward facing parabola, we only have a maximum value. We don't have a minimum value, right? So with that logic, we know that a is greater than 0. That is one thing, and it will come handy. It will come very handy later on, right? So we know that, right? Now let's look at more information that we have. Okay, so one more thing that we can do is we know that the polynomial is p of x is equal to ax squared plus bx plus 8, right? And we have one of the points, right? We have a point 2 comma 6, right? Which is our minimum value, right? So again, let me draw the parabola here. So if this is the parabola, right, and maybe this is some x and y axis right here, right? Y and x. So 2 comma 6, this is our 2 comma 6, right? That is also something we know. Now, what I can do is I can find a relation of this polynomial in terms of a and b. What I'm going to do is I'm going to plug in 2 and 6, right? So x is 2 and p of x is 6. So if I do that, what I get is 6. 6 is equal to a times 2 squared plus b times 2 plus 8. So 6 is equal to 4a plus 2b plus 8. Okay, simplify this a little bit more. What I get is 4a plus 2b is equal to minus 2. Right, simplified a bit more. What I'm going to get is 2a plus b is equal to minus 1. All right, so this is the simplified relation that I have. Now we have one more relation. We know that the lowest point, right? So the lowest point of x is equal to minus b by 2a, right? That is our x, like, right? That is the lowest point. And the minimum value is minus d by 4a, which is equal to 6. So here, this is y, or this is also equal to 2, and this is, this is equal to 2, x is equal to 2, and y is equal to 6. Right? Now, I'm not going to use this because this is kind of complicated, right? I need b squared minus 4ac on top. I'm going to use this because I have a relation of minus b by 2a here, and I have 2a plus b here. So I can, what I can see is I can see a simultaneous equation being formed where I can make some substitution and find the value of a and b, thus find the value, thus write the entire quadratic function again. All right, so I know minus b by 2a is equal to 2, right? So I know minus b is equal to 4a, or b is equal to minus 4a. I have this relation with me also. So what I'm going to do is I'm going to make a substitution, right? I'm going to make a substitution here. I'm going to put, for b, I'm going to put minus 4a. So I'm going to have 2a plus minus 4a is equal to minus 1, right? So 2a minus 4a is going to be minus 2a is equal to minus 1. A is equal to minus half, right? So a is equal to minus half. So that is the value of a I have. Now similarly, I can go ahead and find the value of b, right? Nothing too crazy. So b is equal to minus 1 minus 2 times minus half. This becomes positive, this cancels. So I'm going to be left with b is equal to minus 1, and this is going to be minus 1 as well. So I'm going to have b is equal to minus 2. Did I make a mistake anywhere? Let me just check really quickly. So this would have been minus 2 times half. I had written minus half earlier. It would have just been half. Okay, so it comes out to be b is equal to minus 2. So now I've found the values of a and b. If you want, I can rewrite the polynomial again, right? Not a big deal. So if I rewrite my polynomial, I have p of x is equal to minus half x squared minus 2x, and c was 8, right? Plus 8. That is my final polynomial. All right, all right, second example. Consider the quadratic polynomial f of x is equal to x squared minus 4ax plus 5a squared minus 6a. Find the largest distance between the roots of the equation when f of x is equal to 0. All right, so there are two parts. First, we need to find, we need some way to find the largest distance between both the roots, right? That's the first thing we need, right? That is the first goal, right? Second thing, we will have some sort of a function, and based on that, we have to find the maximum value of the function. And to find the maximum value, we're going to use the property that we previously learned, right? All right, so let's get started. First, we have let's say that we have two roots, right? So x is equal to alpha and beta. These are our two roots. Now we have to find the distance between them, right? Forget the large distance. We just have to find the distance, right? So if we have to find the distance, we have to do something like alpha minus beta, right? Or we have to do the modulus of alpha minus beta, right? Because we have to find the distance, right? We just care about the positive value. We just care about the magnitude of alpha minus beta, not the sign of it, right? So now we know how do we do this, right? Well, we know if you use the quadratic formula, x is equal to minus b plus or minus square root of determinant, right? I'm not going to write the entire thing. Determinant all over 2a. So now if we break this apart, we have two roots, right? We have minus b plus determinant upon 2a and minus b minus determinant all upon 2a, right? Now if we subtract them, right? If we find the difference, right? What's going to happen in this is going to be plus, this is going to be plus, right? And now they have the common denominator, so it doesn't matter. So minus b and minus b plus b will cancel. So we're going to have 2 times square root of determinant all upon 2a. 2 and 2 will cancel, so we're going to have square root of determinant upon a, right? So now what we've done is, okay, I'm just going to rewrite everything I've done here. So what I can say is alpha minus beta is basically square root of determinant upon a, right? Now one more small adjustment or change I'm going to make here is that I'm going to write a as the modulus of a, okay? Because again, I want a positive answer. There's a good chance, because we have to find the largest distance, we're going to have to find a maximum. And the only time we can find a maximum is when we have a downwards facing parabola. And the only time when we have a downwards facing parabola is when a is less than 0. So there's a good chance that a will be negative, and therefore I've put a modulus sign around it. All right, so now that we have the formula in place, all we have to do is just plug in what we have. So if I plug in all the stuff, right, what I'm going to have is square root of this, so square root of, so inside the square root, I'm going to have 16a squared minus 4 times 1 times 5a squared minus 6a, right, all upon 1, right? Simplify this a little bit more. Alpha minus beta will be, I won't write this every time, so I'll just do it like this, and I'll have something like 2 times 4a squared, so 4a squared minus of minus 5a squared minus 6a, something like this right here, right? Simplify this a little bit more. I'm going to have minus a squared plus 6a. Okay, so now this is my final value, right? Now I have to find the largest distance. Thus, I have to maximize a minus a squared plus 6a, right? So if I have to find the maximum value of minus a squared plus 6a, let me just focus on that part itself. And now I'm going to do the very interesting thing here, right? I'm going to change the color, and I'm going to make it a little bit different. So let's take magenta, right? I'm going to let a new function, right? Let g of x be minus a squared plus 6a. That's going to be my new function, okay? That's going to be my new function. And basically the maximum value of g of x, right? The maximum value of this entire function will give me the maximum value of the square root, and therefore I can find the maximum distance between alpha and beta, right? That is the entire process now. So now I have to find, let me, you know what, I'm going to do something like this. Not g of x, I'm going to do g of a, right? So because it's in terms of a, so I'm going to keep it in terms of a. So the function is g of a is equal to minus a squared plus 6a. And like I said, see, a is negative 1 here, right? The value of a, or the coefficient of a squared is minus 1. Like I said, it's going to be negative. That's why I put a modulus sign here before, right? So now let's use the formula d squared minus d squared by 4a. So minus d squared minus g by 4a. Right, this will give me the output, right? The value of the maximum or the minimum value of the output, right? So if I do that, what I'm going to get is b squared minus 4ac upon minus 4a, right? So if I do that, what I'm going to get is minus of 36 minus 0 all upon 4 times minus 1. Simplify that, I'm going to get 9. Okay, so the maximum value, suppose I have a function right here, right? I have this, and it's going like something like, I don't know, like this, right? This is a polynomial, it's going something like this. So the highest point here is basically 9, right? That's what I just did, right? So now I know that the maximum value that this polynomial or this quadratic function can achieve is 9. So all I have to do is now just have to plug it back in. I'm going to change the color back now. So changing the color back, I'll make a small arrow like this. So I know the maximum value is 9. So alpha minus beta is just 2 times square root of 9, which is 6. So the maximum distance I can have between these two roots is 6. This question says, find the range of f of x, where f of x is x squared minus 5x plus 4, when we have, you can see x belongs to 0 and 2 inclusive, and 0 and 3 inclusive. So what we have is a restricted domain here, right? So ideally, what we do here, so I've taken a very simple function here, right? I could have given a more arbitrary function, but I feel that would have made this concept a little more difficult to grasp. So there's a very step-by-step process what we do here, right? So what we try to do is we first try to visualize or try to draw a rough graph of the given function. In this case, this is so simple. I can actually plot the points on the graph and then determine the range by using probably like a graph paper or something. But if we had a very arbitrary, complicated function, right, we can't really do that, right? If we have roots in if you have roots in decimals that go on forever and ever, that becomes very difficult to do that. So right, you can tell by this, 1 and 4 are roots in this case, and then you can work it out and stuff like that, right? But I'm going to show you the proper method. You can always apply that if you get a very simple function like this, but I doubt you ever will, right? IB will never give you such a simple function. And probably this is like a paper 1 question on calculator, because they don't want you plotting the curve and then determining it, right? That kind of defeats the purpose of understanding this concept altogether. Anyways, let's get started. So I know this curve, because a is greater than 0, I know it's an upward facing parabola, right? So that's the first thing I'm going to do. I'm going to try to get a visual of it as best as I can, right? So it's an upward facing parabola. It doesn't really matter, whether I draw it like this or like this. As long as I draw an upward facing parabola, my conditions are satisfied, right? So I have, maybe something like this, right? Now, the key here is to determine the vertex, right? The turning point of the parabola, right? So this is the turning point. Now, what we know about a parabola is it's symmetrical in both left and right of the vertex, right? So maybe if the restricted domain was from like here to here, then I would have a lot of similar points, right? Going back and forth again, right? So the whole point is, the first thing we do is we always find the vertex, right? The vertex is basically x is equal to, if I denote as x naught, it's minus b by 2a, right? So this point is x naught, right? X naught comma something, f of x naught, right? Something like that. So just a second. So like this, right? So x naught is minus b by 2a, right? Minus b would be minus of minus 5 upon 2 times 1, right? So my x naught, or my turning point, is at 2.5 or 5 by 2, right? Right here. Now I know that, right? Now what I'm going to do is I'm going to slightly rearrange this graph, right? I'm going to redraw this graph just so it's easier for me to work with, right? I'm just going to draw a normal parabola like this, right? And I'm going to draw just a horizontal line, right? Or you know what? I'll take the horizontal line just a little high. I'm going to assume it's something like this, right? So I have my one root alpha and one root beta. I don't know what they are. Technically I do, but I'm going to act like I don't, right? And this vertex is their midpoint, which is 2.5, right? So now what I do is now I look at the restricted domain. So my restricted domain tells me to find the range from 0 to 2, right? So if I look closely, if this is 2.5, 0 is somewhere around here, right? So 0 has to be somewhere around here, right? It's not going to be here. It's going to be past this, right? Obviously, it's going to be past this, right? Doesn't even 0 might even be here, right? It doesn't matter, but it's beyond. Let me create a dotted line here. So it's before this vertex, right? It's before the turning point. So what that tells us is that there's going to be a continuous range, right? The values of f of x will not repeat. That is the key point here. So all I need to do at this point, listen very carefully, all I need to do at this point is just find value of f of x at 0 and f of x at 2. Once I do that, game over. That is, my game is done. I've found the range of part A, right? So that's exactly what I'm going to do, right? Think about it logically, right? I have to find basically, because I know two will be somewhere here, right? So even if I've drawn this inaccurately, right? 2 is going to come before, right? 2 is going to be anywhere from here to here, right? Doesn't matter, right? Let me again explain. 2 could be anywhere from here to here. I don't know. All I know is that there's going to be it's going to be like a 1-to-1 function at this point. If I just look at this part, if I just look at the function at this part, right? That is the key point here. Once I've understood that, I know that for every single value of x, there's only going to be one corresponding value of y, right? They won't repeat. Like, how we have a normal parabola, we know that for normal parabola where f of x is equal to x squared, we know that -2 and 2 have the same output, right? We know that. But in this case, it's not going to happen because I've restricted the domain, right? So now, like I said, all we have to do is find the value of f of x at 0 and f of x when x is equal to 2. So let's go ahead and do that. So f of 0, or let me do it further down here. So f of 0 will just be 4 because this will be 0, 0, and 4, right? Where f of 2 will be 2 squared minus 5 times 2 plus 4. So this will be 4 minus 10 plus 4, which will be -2. So f of 2 is -2, and -2, yes, and f of 0 is 4, right? So now I can say that my range is from -2 to 4 inclusive. That is why I've put the square brackets, right? That is why. Now let's look at part 3. Part B says, now I want to find the range from 0 to 3. Now, here is the tricky part, right? So from 0 to 3. So 0 again will be somewhere here in this range. I don't know. But 3 is going to be somewhere here, right? 3 is going to lie somewhere here. I don't know where it will be. Maybe it's going to be like a million miles away there, or it might be just be here. I don't know, right? But what I'm going to do is I'm going to first find basically look at the vertex again and then determine what it is. Now, before I start explaining this, thoroughly, I recommend that you pause the video and try part B on your own. One hint that I do like to give is that do not find the values of f of 0 and f of 3 and whatever the values are between them, that is your range. That is not going to be the case here. All right, so let's look at this in detail. What I'm going to do is I'm going to copy this graph. Okay, so I'm going to copy this graph again, and I'll make a copy of it again and use it for part B. So copy and paste right here, right? So part B. All right, so like I said, we know that number 3 or x equal to 3 will be somewhere on this side, right? We know 0, let's assume 0 to be here. We don't really care, right? But x equal to 3 will be somewhere here, maybe here, somewhere here. I don't know, maybe it could even be here, or it could be like right here. We don't care, we don't know, and we don't care. It doesn't matter, right? Because we're working conceptually, it doesn't matter. So now, the important concept or the important part, the key takeaway is that it's past the vertex, okay? It is past the vertex. So what's going to happen is, if 3 is here, right? If x equal to 3 is here, right? So now if you look closely, there are values of f of x are going to be repeating, right? Maybe there's some value of here and some value of, if 3 is here, right? Let me use a marker here. So if 3 is here and this is some arbitrary value, right? So there's going to be some value corresponding for 3 here And for the same thing, there's another x value which will correspond to the same thing. So now values are repeating, right? So to find the range, right, we're not going to be going from here to 0. Let's assume f of 0 is somewhere here, right? So if f of 0 is somewhere here and f of 3 somewhere here, we're not going to look at these values only, because we're going to forget this small portion here, right? We're going to forget the small portion here, which we cannot forget, because that is still including the range, right? It's 2.5 is there, 2.75 is there, 2.999 is there. We don't know, right? So we can't really ignore this portion, right? Can't ignore, right? We can't ignore this portion. We have to find this part as well, right? So now this is where the concept of finding the lowest or the minimum or the maximum comes in, because now what we're going to do is we're just going to find the highest portion. What we're going to do is we're going to find f of 0, we're going to find f of 3, and we're going to find the maxima or minima. In this case, it's going to be the minimum, because we know that a is greater than 0, and therefore it's going to be an upward facing parabola. Thus, we will have a minimum. Sorry. So what I'm going to do now is I'm going to find three things. I'm going to find f of 0, I'm going to find f of 3, and I'm going to find the vertex, right? I'm going to find the value at f of 2.5, right? Like this, right? So I'm going to find three things, right? So let's go ahead and do that. So I know f of 0 from the previous part is equal to 4, okay? F of 3 will be 9 minus 15 plus 4. I just plugged in the values for 3. X equal to 3, right? That gives me minus 2, right? And I'm going to find f of not just minus, just 2.5, right? 2.5. Now I can do this multiple ways. I can use minus d by 4a, or I can just simply plug in 2.5 into this function right here, and I'll find the value, right? So there are multiple ways. So I'm going to use minus d by 4a just because I like it. So, right? So I'm going to have b squared minus 4ac. So b is minus 5, so I'm going to have 25. So b squared is 25 minus 4. A is 1 and c is 4. So I'm going to have 4 times 1 times 4 all over 4 times a. A is 1. So this. So f of 2.5 will be minus, right? Don't forget this minus sign up here, minus 9 by 4. So now that I've found the minimum value of the function, now I'm going to compare, right? I'm going to see. I want to get the range from 0 to 3, and know that it's going to pass 2.5 to get to 3, right? 0 has to get to 3 from 0. I have to go to through 2.5, 2.6, 2.7, and to 3, right? So let me highlight them. So I have this, and I have this. Now, if you look at this, I could, by just finding values of f of 0 and f of 3, I can say, oh, my range is going to be minus 2 to 4 inclusive with the square brackets, but that would be wrong, right? Because I also have to include this, right? This is my lowest point, because I'm going through here like this, right? Or I'm going through here like this. As I'm going through, I'm basically touching these points and going to the lowest point, hitting the lowest point, and then going to f of 3. Right? So I'm not really going to include this. I'm going to include this and this as my range. So what is going to happen is my final range, right? My final range will be minus 9 by 4 inclusive up to 4. So it's going to be something like this. And that will be my range for part B. Sorry, not 3, 4. All right, next question. Find the difference between the least and greatest values of y is equal to minus 2x squared plus 3x minus 2 for the constricted domain of x between 0 and 2 inclusive. All right, it's a very similar question to the previous one. I highly suggest you pause the video and try it on your own. All right, so let's get started. So first thing, again, it's a very step-by-step process, right? First thing I'm going to do is I'm going to draw a general curve, right? Just to give myself a good conceptual and intuitive feel for the entire question. So I know it's a downward facing parabola because a is negative. So I'm going to draw downward facing parabola, right? I'm just going to draw the parabola. I'm not going to draw the axes or anything, right? Just to give myself a feel for what's going on. Next thing I'm going to do is I'm going to find the vertex, right? So to find the vertex, I'm going to write x naught is equal to minus b by 2a, right? So now minus b is negative of 3 upon 2 times negative 2. So x naught is 3 by 4, right? So this point, right, something like this, I can say, and maybe I'll draw like a line like this. So this is 3 by 4, right? Some 0 is somewhere around here. 0 could be here, here, here. I don't know. I don't really care, right? So I know 3 by 4 is here. So 2 is going to be somewhere here, and 0 is going to be somewhere here. So now, again, what I'm going to do is I'm going to find f of 0. I'm going to find f of 2, and I'm going to find f of 3 by 4. Okay? That is what I'm going to do. So f of 0, by common sense, I can say it's the y-intercept, so it's got to be 2, minus 2, right? So f of 0 will be minus 2. Now, f of 2, again, all I have to do is just plug in the values of into x. So I'm going to have minus 2 whole squared plus 3 times 2 minus 2. So f of 2 will be minus 8 plus 6 minus 2, and which will give me f of 2 is minus 4. Okay, so f of 0 is minus 2, f of 2 is minus 4, and f of 3 by 4. Now f of 3 by 4 looks a little bit complicated, but I can use d by 4 minus d by 4a to find that, to find basically this value. I can use minus d by 4a, or I can just plug it into the function. So I'm just going to plug it into the function, right? So f of 3 by 4, it's going to give me minus 2 times 9 by 16 plus 3 times 3 by 4 minus 2, right? Which is going to give me, if I simplify this a little bit more, 3 by 4, it's going to give me minus 9 plus 18 minus 16 upon 8. Okay, so that's what I'm going to get. And so f of 3 by 4 is going to be minus 7 by 8. Okay, so again, now what I noticed, like part B of the previous question, is that I'm going to have some repeating values, right? I'm going to have some repeating values, right? If I trace this parabola, I'm going to have some repeating values like this and this, right? Even if 0 is here and here, I'm going to have some repeating values, right? Even if this is the range of 0 and 2, I'm going to have some repeating values. So what I have to do is I have to consider the lowest value that I get out of all of them and the greatest value I get out of all of them. So the lowest value here is minus 4. The lowest value I get is minus 4, and the greatest value I get is minus 7 by 8, right? So our range in this case is from minus 4 to minus 7 by 8, and they're both inclusive, so I'm going to put the square bracket, right? So this is my range. Now, that's not the exact question, right? The question asked me to find the difference between the least and the greatest value of the function, right? So all I have to do, I just have to subtract them, right? If I just subtract them, I'll get basically my range, right? So that's not my range. This is my it's my range, but I have to find the greatest. So I have to find the greatest and the least values, right? I have to find the difference between them. I apologize. So all I have to do is just minus. All I have to do is just do minus 4 minus 7 by 8. So this becomes minus 4 plus 7 by 8. So this is minus 32 plus 7 upon 8, just minus 25 by 8. Now that I'm finding the difference, right? The sign doesn't matter, only the magnitude matters. So I can just write this as difference is 25 by 8, like this. So that is my final answer. All right, in this question, we have to find the range of a following equation. Okay, so we have equal to 3 raised to the power x plus 1 plus 2 times 3 raised to the power 2x minus 2. All right, so intuitively, if you've done multiple questions, you can see that we'll have to make some sort of a substitution here, right? Because we have an exponential graph, right? Because it's 3 raised to the power x, but we can't really find the minimum and the maximum range that way. So we're going to be converting this to a quadratic, right? Something that we're familiar with. So let's do that, right? So if I make some few changes, I can write this as 3 times 3 raised to the power x plus 2 times 3 of x squared minus 2. So what this does is, now this kind of looks like a quadratic, right? So I'm going to rearrange this again. Squared plus 3 times 3 of x minus 2. Now I'm gonna make a substitution here. I'm gonna let t equal to 3x with the condition that t must be greater than 0, right? It's an exponential curve. T has to be greater than 0 because log of 0 does not exist. So thus, t must be greater than 0. All right. So now that we have settled that, let's make the substitution. So we're gonna have y is equal to 2t squared plus 3t minus 2. Now we have to find the range of it. We can just, we know it's an upward facing parabola. So we know that maximum it'll go till infinity, right? If it's an upward facing parabola, it's going to go all the way to plus infinity, right? It's going to go all the way up to plus infinity. All we have to do is we just have to find the turning point or the minimum. We can do that just by simply using minus d by 4a. So let's go ahead and do that. So minus d by 4a, right? We have this. So let's plug in the values. What we have is b squared minus 4ac all upon minus 4a. So we're going to have is 3 whole squared minus 4 times 2 times minus 2, and then minus 4 times 2, right? So we're going to have 9 plus 16 upon minus 8, right? Or sorry, yeah, so I forgot to put the minus sign up here, see? So like this, and like this, so minus 8. That gives me the range as minus d by 4a as 25 by 8, right? That's what I get. Or have I done everything properly? Yeah, I've done everything properly. I didn't need to put that extra minus sign. So the lowest is minus 25 by 8. So I'm gonna have something like this. So let me just make this a little bit more cleaner. This. So 16, 8, okay, something like that. So I know my lowest point is this. Now we can. You might think that we're done, but this is actually the wrong answer, right? So we have to take care of the conditions that we made because we simplified this question as per our convenience. Now we have to make sure that it fits the condition it fits the original condition given in the question. First thing we have to see is this is the value of y, right? So the corresponding value of t will be minus b by 2a, right? Because that's how we usually find the vertex, right? Or the turning point, right? It's minus b by 2a and minus d by 4a. We've found this. Now let me just check, because that will give me the value of t. And if t is less than 0, then this is unacceptable. We're going to have to make some changes. But if t is greater than 0, then it's all good, right? Then I can say that this is the minimum value and infinity is the maximum value. Question done. But I have to check and make sure. So if I check, right? So minus b by 2a. So minus b, minus b by 2a. So minus b, so 3 and 2 times 2. So this is minus 3 by 4. And we have hit our roadblock, right? So t we're saying that t is less than 0, where we put the condition that t must be greater than 0, right? It must be greater than 0. So now what do? Let's draw the curve. Let's draw a parabola, right? Let's draw the xy. It's the axes first, right? Let's draw the axes, something like this. We know that the parabola is something like this, right? Obviously, something like this because our turning point is negative 3 by 4. So something like this, right? That makes the most sense. So we have minus 3 by 4, comma minus 25 by 8, right? Somewhere down here. Now, what we have told ourselves is that this is t, right? And this is y. So if this is y, and this is t, right? This is t. So we have told ourselves that t must be greater than 0. And here the lowest value of t is negative. So what we're going to do is we're going to take the lowest possible value of t, which is just above 0. So any of these values, right? Any of these values will satisfy the condition, right? So if they'll satisfy this condition, I just need to find the lowest possible value of t after 0. So what I can really do is I can just find the value of t. I'll find the value of y when t is equal to 0. And when t is equal to 0, y is equal to minus 2, right? So when t is equal to 0, y is equal to minus 2. And that is my range. That is the lowest possible value I can get. Especially when I put a parentheses around it, it's not including that. But everything after y is equal to minus 2, I can take that, right? So this is my parabola, and basically I need when t is greater than 0, y is greater than minus 2, right? So this is my range. So now my actual range, not my new range, my actual range becomes, so if I write it like this, range is from minus 2 to positive infinity, and I'm going to put parentheses around both because I'm not including any of them, right? 2 does not count because t is equal, when t is 0, we have minus 2, and when there is no defined value for t equal to 0 right here, because we have put the condition as t greater than 0, right? So our range of this question, or our answer to this question, is minus 2 to infinity. All right, next question. So we have been given this curve, and we're given 2 points, right? Point 1 and point 2. All right, so based on this, we have to determine the equation of the parabola. Let's start with the general equation. We have y is equal to ax squared plus bx plus c. So we know the value of c right away. C is minus 12 because it's the y-intercept, right? So c is minus 12. So I can rewrite this as y is equal to ax squared plus bx minus 12, right? Now, what I'm going to do is I'm going to put the value of x as 2 and minus 16 as y. So that's going to give me this equation in terms of a and b, all right? So now I'm going to have minus 16 is equal to 2 squared, which is 4. So 4a plus b times x, so plus 2b minus 12, right? Simplify this a little bit more. I get 4a plus 2b is equal to minus 4. Divide by 2 on both sides, I get 2a plus b is equal to minus 2. So this is my final simplified equation. Now I also know one more thing. The turning point, right? It's at 2 and minus 16. So I can also say minus b by 2a is equal to minus 16. Right, sorry, 2, not minus 16, 2. And minus d by 4a is equal to minus 16. But I don't really have any use of this because I already have an equation in terms of a and b. I have my second equation in terms of a and b, right? Here I'm going to have b squared minus 4ac, which is going to make things a lot more complicated, right? I don't want. So I'm going to keep things simple. I'm going to use this one right here, right? So b is minus 4a. I'm going to plug that in right here. So I'm going to have 2a minus 4a is equal to minus 2. Minus 2a is equal to minus 2, and a is equal to 1. So there we have the value of a. Now we have the value of c, and now we have to find the value of b. So I can use this equation right here. So based on this, b is equal to minus 4. So now our final equation comes out to be y is equal to x squared minus 4x and c is minus 12. So minus 12. This is my final answer. All right, so let's look at restart. All right, let's look at this question. We're given the y-intercept and the 2. So let's get started. Simple equation, let's start off. Well, we know that our y-intercept is 3, so we know c is equal to 3. So now if you write y is equal to ax squared plus bx plus c, we can replace c automatically with 3, right? Without an issue, right? Now, what I'm going to do is I'm going to make 2 equations, right? I'm going to have 2 equations, one where I'm going to use this root minus 3 comma 0, and one where I'm going to use 1 comma 0. So I'm going to plug in for x, I'm going to put minus 3, for y, I'm going to put 0. Similarly, for the second equation, I'm going to put 1 as x and 0 as y. That's going to give me 2 equations with 2 variables, and I can solve the simultaneous. All right, so let's get started. So I'm going to put 0 here, and I'm going to put a times 1 whole squared plus b times 1 plus 3. So I'm going to get a plus b is equal to minus 3. All right, so that's my first equation, right? Equation 1. Second equation will be, well, I'm going to have 0 here. So 0, I'm going to have 0 is equal to a times minus 3 whole squared plus b times minus 3 plus 3. So I'm going to have 0 is equal to 9a minus 3b plus 3, right? That's going to give me 9a minus 3b is equal to minus 1. Simplify this a bit more. I'm going to get 3a minus 3 minus 3 is going to give me minus 1, right? That's my second equation. So now, if I add them both, right? If I add equation 1 and equation 2, what I'm going to get is 4a is equal to minus 4, and a is equal to negative 1. And that I know I'm on the right track because it's a downward facing parabola. My a is also negative, it's less than 0, so I know I'm on the right track. I can continue. So a plus b is equal to minus 3, minus 1 plus b is equal to minus 3, b is equal to minus 3 plus 1, which is minus 2. So my final equation comes out to be y is equal to minus x squared minus 2x plus 3. Again, very straightforward, nothing too crazy. Let's move on to the next example. All right, next example. So in this example, we're going to do things a little differently. So what I'm going to do is, instead of using, for the previous 2 examples, I used the form y is equal to ax squared plus bx plus c, right, to solve every single question. Here, I don't even know what c is, so it's kind of pointless. So what I'm going to do is, I'm not going to use this. I'm going to use another form. I'm going to use y is equal to k x minus alpha times x minus beta, where alpha and beta are my 2 roots, right? Basically, my value of x when y is equal to 0. So what's that going to do is, and I'm going to have some k constant, because what happens is I also have to consider or take into consideration the width, how wide or how narrow my parabola is, and that helps me, and this k with this constant accounts for that. All right, so essentially what I'm going to do here is I'll explain this step by step as I do it. So I'm going to put 1 for alpha. I'm going to let alpha equal to 1 and beta equal to 5. Or I could do it the other way around. Doesn't really matter, right? And then I'm going to take different values, and then I'm going to put 4 and minus 12 for x and y respectively. And then I'm going to solve for k, right? Whatever the value of k I get, that's my final answer. I'm going to put it here, and then I'm going to write x minus 1 times x minus 5. All right. So if I do that, so I'm going to have y is equal to k times x minus 1 and x minus 5, right? So now, just a second. All right, cool. Now I have this. So I'm going to put 4 for x. So that's going to give me k times 4 minus 1 is 3, and 4 minus 5 is minus 1. So now I'm going to put minus 12 here, right? So I'm going to get minus 12 is equal to minus 3k, and k is equal to 4. Well, I know it's positive. That's good because it's an upward-facing parabola. Hence, my ax squared, or the coefficient for x squared, will be positive. Hence, I know I'm in the right area. So my final equation And I can keep it as this, right? The question hasn't mentioned what form to keep it in. If the question mentioned, yes, keep it in the form of ax squared plus bx plus c, I would open it, but I don't need to. I'm going to keep it as it is. So I'm going to write 4 times x minus 1 times x minus 5. And that is my final answer. All right, let's get the final example question. So we're given the vertex, the turning point, and some arbitrary point on the parabola. So what we can do is we're gonna have to make a couple of relations between the points. And upon making those relations, then we can find the values of a, b, and c. Okay, so let's get started. So we know 2 is the turning point, right? 2 comma minus 6 is the turning point. So we can say that minus b by 2a is equal to 2, and minus d by 4a is equal to minus 6, right? So minus b by 2a is equal to, it's equal to 2, then we can say b is equal to minus 4a. That is the first relationship that we have. Similarly, I can write here, I can write as b squared minus 4ac upon 4a is equal to minus 6, right? So I can simplify this and write this as b squared minus 4ac is equal to 24a, because what I've done is I've canceled this and then I've taken the 4a to the right hand side. Now what I'm going to do is I'm going to make a substitution. I'm going to get rid of the b here. So I'm going to write minus 4a whole squared is equal as minus 4ac is equal to 24a. So I'm going to have 16a squared minus 4ac is equal to 24a. Now if I divide both sides by 4a and 4a, what I'm going to have is 4a here minus c is equal to 6, right? That's what I'm going to have. So I'm going to write this in terms of c. I'm going to write this as c is equal to 4a minus 6, right? So I have one more relationship here, right? So now I'm going to write the original equations, right? So y is equal to ax squared plus bx plus c, right? I'm going to put in the value of, I'm going to substitute the value of x and y with 4 and 6 respectively. So what I'm going to have is 6 is equal to 16a plus 4b plus c. Now, I'm going to replace a, b, and c with the relationships in terms of a. So here, I'm going to have 6 is equal to 16a plus 4 times minus 4a plus c, which is going to be 4a minus 6, right? So 16a minus 16a will cancel, right? This and this will cancel. I'm going to be left with 12 is equal to 4a. So a is 3. So this is on the, I know I'm on the right track because it's an upward facing parabola, and a is also greater than 0. So I know I can move forward without checking my work. All right. So now similarly, for b, all I have to do is just substitute the value of a. So b is going to be minus 12 right here, and similarly here as well. So all I have to do is find c. So which will be 4 times 3, which is 12. 12 minus 6 is 6. So c is 6, right? Final equation, I can write it here. So y is equal to 3x squared minus 12x plus 6. So with this question, we wrap up today's video, and this will end quadratic functions. So I know this was pretty long, almost 4 videos we spent on discussing quadratic functions, but it was necessary because of the different applications that we're going to be seeing later on, especially in calculus, right? You need to know how to find range, minima, maxima, all these sorts of things when you move forward as you continue with IB mathematics, right? So in the next video, we'll take a look at rational functions, right? We'll understand the how f of x is equal to 1 upon x and different variations of that. We're gonna look at how to find the domain, range, and even plot a few graphs, because that's something they can ask in paper 1 where you don't have a calculator, right? So we'll take a look at that in the next video, and yeah. So I'll see you in the next one. Bye-bye.